Hello, welcome to our webinar today. We are coming at you from our Calgary office, where we actually manufacture our analyzers in-house. My name is Kendra Spires, and I'm on the technical sales team here at Envent. And today we're going to talk about our High Range H2S solutions. We've got a couple different solutions for you, and we're actually going to explain how each of those work and walk you through those. So, first we've got our lead acetate tape dilution systems. We've also got our tunable filter spectrometers and our Gaschromatographs. Along with all of those different analyzers, we actually will help you work through your applications and create systems depending on the different measurements you need. First, we've got our M series. We've got our M60, which is our oxygen analyzer, our M70, which is the H2 analyzer, or water analyzer. Our M90 is our carbon dioxide analyzer. Along with those, we have our 330S and 331S, H2S, and total sulfur analyzers. We're going to talk about those a little bit today. We've got our Sulfur Sentry, which is our portable H2S analyzer, as well as our 131 and 132 Gaschromatographs. We'll also talk about those today. We are a rep for Michelle, which we can help you with your water content, dew point, and hydrocarbon dew point measurements too. We have our TFS, also talking about that today, our tunable filter spectrometer. Along with all of those, we actually can help you build your sample conditioning system for your applications. We will look at different pieces and figure out exactly how those sample conditioning systems need to be put together, and we'll create a whole solution for that. Along with all of that, we have our buildings, enclosures, and probe assemblies, essentially a one-stop shop for the entire application. Without further ado, I'm going to hand it over to Al, and we're going to get on with the webinar. Thanks for joining.
All right, thank you so much, Kendra. Sure appreciate the introduction. My name is Al Willett. I'm Northern Alberta and BC Technical Sales Representative for Envent Engineering. So we are discussing with you H2S, so it's important to understand the properties of H2S. It is a very dangerous substance in higher concentrations. So it's naturally occurring, and it's found in a variety of geographical formations. It's in about 1/3 of natural gas that's produced in Alberta. And it is colorless, heavier than air, and extremely toxic. So you have to be careful when you're working with H2S in the industry, whether you're working on our sample systems or anybody else's. In low concentrations, it smells like rotten eggs, and it's one of the most active corrosive components in a gas, air, water environment. Next slide. Thank you. Applications. So some applications for our devices, and like Kendra mentioned, it was either H2S lead acetate tape analyzer, the TFS, or a GC. Applications include plant inlet, acid gas rejection, SRU inlet, H2S scavenger inlet, pipeline blending, wastewater, biogas, and landfill, and then sour wellhead. So the analyzers that we're going to be discussing, the lead acetate tape and TFS, tunable filter spectrometers, and the GCs have specific ranges that we like to specify for our customers. So the ranges that we find these analyzers work most accurately in, for example, the lead acetate tape analyzer with a normal standard conditioning system is parts per billion to 250 parts per million H2S. Now if we add a dilution system, which we're going to describe, and you see one here, is the range is approximately 250 parts per million to up around 10% H2S. And then we step into the TFS, the tunable filter spectrometer, and that is a range from about 1% up to 100% H2S. And then we'll discuss the Gaschromatograph, which the range is approximately 20 ppm up to 100% H2S. So let's step right into the lead acetate tape analyzers and its application in high range H2S. We have, as you can see on the display, we have our explosion-proof housing model 330S, and then on the right we have our NEMA 4 cabinet, which is Class 1 Div 2. First one is Class 1 Div 1. Class 1 Div 2 is our Envent model 331S H2S analyzer. Lead acetate tape, the function and the method in which it measures H2S is the lead acetate tape method. So if you've ever pulled like a Draeger tube or tube pulls on gas, it has a white substance inside the glass tube. That's lead acetate. Lead acetate in the presence of H2S turns brown. So you'll get a stain that occurs on the tube you pull. Likewise, with our lead acetate impregnated tape, you'll get a staining that occurs. It's a chemical reaction that occurs between the lead acetate and the H2S. So with lead acetate, we are using these monitors to provide a linear, interference-free output of H2S. So it's an interference-free method so that you don't have to worry about background gases having an impact, negative impact on your reading or accuracy. So what we have is in the analyzer we have a sensor block, and the sensor block has an LED. It shines light on the tape, and then we have a detector that picks up the amount of reflected light back to the sensor. So essentially the theory of operation is the darker the stain, the more H2S, the more chemical reaction that's taking place. Also included in that is the faster that it's getting darker, then you can tell the concentration based on that. Next slide, please. So lead acetate tape, the analyzer itself, Class 1 Div 1 or Div 2, groups B, C, and D are available. Standard ranges, once again, 0 to 5 parts per million or up to 250 parts per million. Dilution sample systems range from 250 ppm up to 10% H2S. So basically taking our standard H2S analyzer, you're ranging upwards of 250 parts per million. You add a dilution system to the H2S analyzer so we can reduce the amount of H2S going to the analyzer to slow down that chemical reaction I spoke about a minute ago, and we can go upwards of 10% H2S. And the accuracy is about 1.5% of full scale. Repeatability is less than 1.5%. And then, of course, typical communications, Modbus communications, optional Ethernet, and then 2 4 to 20 milliamp signals out. Next slide. All right, so the dilution system that we add to our standard H2S analyzer with a standard conditioning system, we have a dilution panel that we provide that you can add to an existing system or order it with it built right on the same panel. But dilution, if you look at that representation where you've got the carrier coming in and then your analyzer, or then it goes to the analyzer, basically our carrier is a inert gas or sweet gas. So you could run nitrogen, instrument air's the best, and then you can also run natural gas sweet. It has to be sweet or it'll affect your reading of your sample. So you bring your sample in to the bottom of our sample chamber, or into the bottom of our diluter chamber. You bring your sample in, it fills the enclosure and goes out to vent, and I'll describe this in a little bit more detail. But you then have your permeation tube in there inside the chamber that allows only a certain quantity of your sample into the analyzer, and that's how it dilutes it. Next slide, please. So basically, I'm going to describe what's going on here so you can see the sample system on the display. Actually, could we just go back one slide, please? Yeah, let me just describe this first. I want to describe this system first, and then a couple options for sample chamber, or for dilution chamber. So what we do is, it's two systems. So basically we have our nitrogen or methane gas that's sweet, or we can have our air. Instrument air is the best. What we do is we filter, we regulate, and then we control the flow of it. We do that with a critical orifice, and it goes through this non-controllable flow meter, and then it goes into the sample chamber. And this is a broken down one. I've already shown you this. So the sample chamber actually has this permeation tubing inside. It only allows, like I said, a certain amount of gas into the stream of your carrier, so your nitrogen, for example, or your instrument air. And what happens is your sample is sitting inside this cavity. It's flowing through it. So it comes in and out. It's constantly flowing, constantly refreshing your sample. This one is an example of if you don't want very much H2S going to the analyzer because it's high concentration. So you have a higher concentration of H2S, you're going to have a shorter length of permeation tube inside that sample chamber. Another example here is a longer one. So this one will be used if you have a lower concentration of H2S in your sample, so you need to allow more time to absorb into your carrier to bring it to the analyzer to be read accurately and repeatable, have good repeatability. So longer permeation tube is used for the lower concentrations, hence the longer tube. We don't want to jam pack a bunch of that permeation tube into a small container. You want to allow the best opportunity for absorption, greater surface area. So that is high range and low range permeation tubes. So now in describing this system, we have our carrier flowing through our permeation tube inside our diluter, and then we have our sample coming in. So our sample is filtered, and we've got a speed loop or a sample sweep, so we can go back to process with that. So we filter, regulate, come through our tubing, we flow control it with a controllable flow meter. We go into the area, the cavity of the diluter, filling it and replacing it, constantly flowing through, and then we go back out to either process or low pressure flare. Okay, so now we'll go into a rendering or a video of how this works. So you can see the molecules, you can see the blue molecules, which would represent air, for example, or no H2S gas or nitrogen. It's flowing through the top section. And then you can see the yellow molecules, which is your sample gas with H2S in it. So it's flowing through, and then now you can see what happens in the diluter area. You're carrying a small amount of H2S going off to the analyzer up on the top left of your display. So now we've discussed dilution sample conditioning system in front of an H2S analyzer, the lead acetate H2S analyzer. We have another type of dilution. It's our dilution probe, and what it does is it allows you to measure the headspace of a vessel or a tank, like in wastewater, for example. So what we do is we basically have mechanical protection around our dilution or our permeation tubing. This is quite a bit of permeation tubing. The length is basically determined on your application, how much H2S you're expecting to measure. We bring a certain amount of H2S to the analyzer so the analyzer can measure that. So that's our dilution probe. So now what we're going to do is we're going to step right into our next application. So we did lead acetate application using dilution for high range H2S. Now we have what we call a tunable filter spectrometer. The spectrometer basically operates on the principle of infrared light. So we take our infrared light, we shine it through the path or through the sample chamber. The path follows through the sample. It's reflected back and hits our detector to be measured. So what we do is we take our sample in, and our electronics and our mirrors are separated from the sample. They're not in contact with the sample. So the sample comes into the chamber, it flows through the sample chamber, and what it does is it allows it enough time to stabilize in pressure and temperature so that when it leaves, by the time it leaves the sample chamber, we get a good representative sample of H2S being measured by the TFS. Now the TFS basically measures, we use it to measure H2S, but we can also use it to measure carbon dioxide and hydrocarbons as well. So the sensor provides a continuous wavelength sweep within a narrow wavelength band using this rotating filter. So this rotating filter, which you can see here, it just sits and rotates continually, and that allows us to measure different bands of or different wavelengths of light. So now what we can do is we can utilize this device to measure, next slide please. We can use this device to measure CO2 and H2S using part of the filter, and then the other part of the filter we measure the rest of our hydrocarbons. The range that we're dealing with is about 1 to 100% H2S, and it can actually alarm and give you an indication in as little as 1 second up to 10 seconds for a response. Next slide, please. So now we're going to step into our gas chromatographs. GCs, Envent's GCs, we've got a Class 1 Div 1, we've got a Class 1 Div 2. Class 1 Div 1 is 131, and the 132 is the Class 1 Div 2. So with respect to our gas chromatograph, they measure up to 16 components, including CO2, N2, and H2S. So what we basically do is some basic theory on gas chromatography. If you had a piece of tubing filled with some kind of media, which these ones are, we call those columns. You have it a specific length so that if you inject your sample in the end, by the time it gets all the way through that media, it breaks out each component individually. Now, if we did that with one piece of column and one particular media, the issue you have is time. It would take hours to separate your lights and your heavies, specifically your heavy components. Heavier components take a lot longer to travel through that same media. So what we do is we have a process where we use a switching valve and a group of different columns that have different media in them so that you can actually reduce the length of analysis time. We're at somewhere around 5 minutes, depends on your application. Next slide, please. So we can show you a representation of what happens. Basically, we inject our sample into our sample loop, so it's constantly flowing and goes out the vent. Then when we switch our valve 1, it takes a different route and it gets injected into the first column. The first column then quickly allows the lighter components to pass through it and get out of that column. Then what we do is what we call backflush. It flushes those heavier components back out to go and be measured through another column. So in a nutshell, basically what we're doing is we're switching the valve and allowing rerouting of specific components at certain times to go through different media so that they're allowed to separate. They separate out enough so they can go past our detector and be measured. And in the video presentation you can see there, as it passed through a thermal conductivity detector, it gets picked up and measured at that point. And then after all the components come out through your TCD, they are all measured on our chart file. Okay, next slide, please. So with the Gaschromatograph, you get it class 1, div 1 or div 2, groups B, C, and D. Some applications are SAGD, biogas, landfill, plant inlets, sales and outlet, and sour gas pipeline blending. So we measure C9 plus with hydrocarbon dew point and C5 plus in condensate. And we've got data logging and the typical outputs, so 4 to 20 milliamp output, and serial Modbus and TCP communications. Next slide, please. So we're going to just end with a few of the benefits of each of these 3 devices. So the lead acetate tape, very simple in design, very cost effective. Price is a very good price point on the device itself, plus the maintenance isn't very expensive. And one of the greatest advantages is no interference, and of course, as we've already described, we can measure high range H2S using a dilution system. Easy field cal and measurement Canada approved. The TFS, some benefits of the TFS. Greatest advantage is its response times. It's as fast as 1 to 10 seconds for results, which is kind of unparalleled in the industry. And it requires no carrier gas or instrument air, first principle measurement, and the sample cell pressure and temperature is compensated internally, and we also offer stream switching for the TFS. And now the Gaschromatograph, they're designed to operate for remote production areas, not a lab GC, operating in dirty samples, no instrument air required, very limited maintenance, and again, stream switching is available for multiple streams for the Gaschromatograph. It provides full compositional measurement, and one of the greatest advantages for Envent is quick turnaround. We can offer very fast delivery times. So thank you very much for being part of this. We appreciate your attendance. We welcome you to visit us, call us, join us online, watch out for some upcoming sessions, some upcoming webinars, and our video will be available on our YouTube channel. And please don't forget to complete the survey and tell us what you would like to learn next, or if you want us to expand in any area of what we have covered today. So thank you very much. Have a great day.